Good day everyone. Today we will explain to you the TCPIP model.
What is TCPIP model? TCPIP basically stands for Transmission Control Protocol, Internet Protocol. It is a model for standardizing computer networking. TCPIP allows you to specify how a specific computer should be connected to the internet and how data should be transmitted between them. When multiple computer networks are linked together, it aids in the creation of a virtual network. TCP/IP has 4 simple layers which are numbered from bottom to up. Starting from the 4th layer, application, the highest layer, defines the interface between host programs and transport layer services. Next to it is the transport, which oversees ensuring error-free data delivery from beginning to end. Then next is the internet, which we are all familiar with, specifies the protocols for logical data transmission over a network. Finally, the link, which is a category of networking protocols that only operate on the local network segment to which a host is connected. These 4 layers are the original layers of TCP/IP, but it has been updated, adding an extra layer and renaming one layer. The renamed layer was Internet, which then became Network. The link layer was divided into 2, making the second layer the data link and the first is the physical, just like in the OSI model. As we all know, the OSI model has 7 layers, which are the application, presentation, session, transport, network, data link, and the physical. Comparing it to the updated version of the TCP/IP model, the presentation and the session layers are not included and instead it was only application. Despite of the small difference, both models' data is divided into packet and each packet may take its own path from the source to the destination.
Originally, the TCP or IP model has 4 layers, such as network access, internet, transport, and applications. These layers form a protocol suite when combined. When the user provides data, the TCP or IP model sends it via these layers in a specific order, which is then reserved when the data is received. So let's remind ourselves about the protocols and devices such as HTTP, FTP, and SMTP. The 2 most common layer transport protocols are TCP and UDP. Port numbers are also added here. At the network layer, we have the Internet Protocol, or such as the IP. Routers also operate this layer. The data link layer contains Ethernet switches typically at this layer, although you can get layer 3 switches that have some routing capabilities. Finally, we have the physical layer. Think of everything we can touch and feel here. Things like cables and network interface cards. And okay, so as we send data for each layer, we'll add its own bit of information. This process is called Encapsulation, when they hit the physical layer when the data is transmitted. Later on, we will learn about how the data will be transmitted.
Now, we will discuss about the process of encapsulation. As you can see in this slide, this shows the process of encapsulation and the encapsulation. Every time we send the data, this layer will add information to the data, and this process is called encapsulation. The data will transmitted every layer from application to the physical layer, and after reaching to the physical layer, the data will transmitted over to the receiving device and where the encapsulation will happen, where the data decapsulate or transmitted every layer from physical to application. To the next slide, we will tackle about the process of encapsulation and the encapsulation.
Let's now proceed on the detailed information about the TCP or IP model. Here we have seen the 4 layers of the said model. These are the application, transport, internet, and the link. These 4 layers were included in the idea of building data and methods that work on that data within one unit. And this concept is also often used to hide internal representation or state of an object from the outside. This process is called the data encapsulation. We start off in layer 5 as we creating data with the application that will be created and the program would be appended its header. This data could be the two protocols including the Hypertext Transfer Protocol or HTTP and the File Transfer Protocol or FTP, which are responsible in downloading and uploading files between a server and a client over the internet. It is also provide various web pages from the web browser to the web server. After this, it will be sent down to the transport layer. The transport layer is going to add a header using the protocol, and one of the protocol used in this layer is the Transmission Control Protocol or TCP. It is used for organizing data in a way that ensures the secure transmission between the server and the client. However, this time we are not using terminology like protocol data unit or the L7 header and L6 header because it's associated to the OSI model. Here at the fourth layer, the header that is applied and the data behind it is referred to as the segment. In addition, keep in our mind that the header contains the sequencing information so that the data segments can be reassembled at the receiver's end.
We then move to the network layer where IP header is added. This will contain the source and destination IP address as well as other bit of information. Lastly, we have the data link layer where header and trailer is added. The header contains mainly the destination and source MAC address, and the trailer contains the error checking information to check and make sure the data has been received correctly. Once data gets the physical layer, it is physically transmitted. Now the encapsulation process has ended. It is important to know that at each stage, the data has a specific name, which is, as said a while ago, once the transport information has been added, the data is now called a segment. Once network layer is added with information, it now makes the segment a packet. And finally, once data link is added with information, the packet becomes frame. Now, once data has been transmitted, the receiving computer decapsulates the information. It will check the destination MAC address for that frame, and if the frame is destined for our computer, it's processed further. The computer then checks the IP information of the packets, the transport information is read, and the application data is sent to the receiving application. So that's it for the TCP/IP model. Thank you for listening.